Hello everybody. I needed a benchtop multimeter so I could, when I went back to my bench, I could find it because I kept taking my hand check. This has been my go-to meter for a few years now. I've had 4 or 5 of these. I've blown some of them up and others have failed. Others have been dropped. So probably 5 I think. But they're about 30. The first one I bought was about £25, but now they are probably about £30–35. But they're very good, except when you're outside in bright lights like daylight, you can hardly see that display, and outside on an overcast day like today but bright, you can hardly see what it says. So it's definitely for indoor use, not under bright lights. Okay, and of course this thing just switches off. It after it goes on for a while, it goes beep, goes off, starts beeping at you, and interrupts the video, and you have to press the select button to wake it up. And it's just a bit annoying when you're doing a video, or when you're in a hurry and you're thinking deep thought and suddenly your meter goes off and it can disturb your train of thought. So anyway, I thought I'd get one of these, and I've got this. Had a look around. This is the XDM1241 from OWON, benchtop multimeter. Quite small but fairly solid, quite weighty. This one is the 1241, which has got lithium batteries in it, so you can recharge it and use it away from the bench without a power supply. The 1141 hasn't got lithium batteries. It's only power lead powered, if that makes sense. And so I think for the extra $5 or $6 or whatever this was from AliExpress, I went for the one with the batteries. Now this was sold, AliExpress did a special offer which was back to school offer recently, which was about a week ago, and I'm guessing they wanted to sell these into school labs and things like that, and science departments, because this was on offer at 20 quid off. So it was typically 120 quid on AliExpress and Amazon, but I got it for about £85 landed and delivered. Anyway, so it's a multimeter. I just turn it on. There is an auto power off setting you can access during utilities, and you can put a timer at 30 minutes, an hour, or whatever you want, but I just leave mine on all the time because I'm using it on a daily basis on the bench. Right, it's got about I don't know, the screen is only, if you look at it that end on, you can see there's the base there, that's the line of the base. The screen is only angled maybe 10 or 12 degrees. I think if it's not on the shelf and you're using it on the deck, it could do with being slightly higher, greater angle, make it easier to use. I think I might just 3D print a little stand to put it on, so that when I punch the buttons it doesn't fall over. Okay, so I think I'm going to make a little 3D, just a prop stand for it to make it more useful. Actually, I should have done it before I started this video, then you could, I wouldn't have to hold it for you, because if I go like that, you see my overhead ring light. I haven't got my main lights on because the display is adequately bright, but with that other lights on, you can see it doesn't do the display justice. It's actually quite a bit brighter than that if you're here in the flesh looking with eyeballs. Right, anyway, so come back, here you come. So yeah, VDC. Think about some of the things on here which are interesting. On the utility, you can set the backlight language, everything else. You go next and you can put the power on. Now that power on is to the last setting, so if you're on amps DC, it would come back on when you power on amps DC. The trouble is, if you'd set a range with it, if I go amps DC now and then I set the range, so you can see the range changing here, 5 volt range, auto, 5 volt, and you go range. You can then select the fixed range you want. Okay, so on AC we've got now we're on the whatever it was range, 50 volt range. Okay, now that's nice. So that when you power off though, if I power off and power back on, you can see the range has gone back to auto. That wouldn't necessarily be a problem, but the auto ranging on this meter on some of the functions is pretty slow actually compared to the old Mestec. and it's much quicker if you select the range. I mean, I'm not working down in millivolts all the time, so I'd quite like it to go range. I quite like it to just be on 500 volt range all the time, and when it goes back off or when I turn it on, it's on 500 volt range. But with the utility and the last setting, it comes up to the last button that was pressed on here, but not the range that it was in when it was switched off. So an incapacitance, that's particularly annoying as well. So that's one thing I think they should change the software to make sure that it comes back in the range, the setting, like volts DC or amps AC or whatever, and the range that you set it to, so you don't have to muck about with the range every time you power it up. Just a thought. Anyway, so I'm not going to particularly go, I think there are reviews of this, and to be honest, I think a meter with this many decimal points, with the accuracy that this one's got, is pretty pointless. I mean, there's no point having displays with 0.1 of a millivolt unless you're using the relative function. The relative function will take any, whether you're on DC volts or whatever, you press the relative button to on, say it's set to 100 volts and you want to measure the delta from 100, i.e. the voltage you're changing from 100 or the current or whatever it is that you're changing, you can switch rel on and it will zero the display. Then you can see the increase and decrease, so you can see fluctuations about a normal voltage, which might become useful in development and stuff, but put rel off for now anyway. So you press volts once, volts AC, you press it again to get AC, amps AC, and then you've got your resistant ranges. It goes in overload all the time. It's now, the resistance ranging is quite slow. Again, you can go and put the range on, so you could have, say, a 5 mega ohm range. Still there, but it'll home in onto the value of the resistor you're putting more quickly if you have the range selected. So I'm going to go, and also you can do difference in range, resistance as well. So all of these things you can set the current setting as the zero line effectively, and look at the deviation to and from that zero line, which could become useful sometimes. I can't think of when I've wished that I've had that, but I've got it. I might use it, if that makes sense. Anyway, so relatively off, range will have auto. There we go. So then the ohms, press it again, you get the diode forward voltage reading with a threshold of 0.5 volts, and that threshold there is the threshold it sets, that if the voltage across the die goes below 0.5 volts across the connections here go below 0.5 volts, then the beeper will sound, and you can turn the beeper on and off on the diode continuity mode or the diode forward drop mode for checking diodes and transistors and such things. Resistance, and then we've got continuity, beeper on, and again the threshold for the beeper, and we're on continuity for that, so buzzing out boards. And I quite like the threshold, because if you're buzzing out a board and you're looking for trackings, you know, it beeping at 50 ohms is just annoying really. If you're just doing it gives you more control basically on what you're actually looking for on the board, and it might save time. The good thing is that this, when you've on continuity and you just briefly touch the probes together, there's a short delay before it beeps, and if you touch and then it breaks continuity quickly, it doesn't beep. So even though there's continuity there, you don't get the beep, although you see the display change. On this one, I've checked it, it goes instantly. As soon as those probes touch, the beeper sounds, and it extends the beeper to make you aware that there has been a continuity connection there on the input. So capacitance is another thing. Auto ranging capacitance is very slow. If I just I'll demonstrate the slow capacitance in a moment, but again, I would never really be measuring this with the nanofarads range, because you've got your leads, you have got a relative to cancel out the capacitance and the inductance of the leads probably, but it's pretty meaningless having that. And then on the capacitive range, I would probably be using this most of the time on probably measuring electrolytic capacitors on the board. If I want to measure capacitors and film capacitors and accurate polyester capacitors and timing capacitors, then I'll use the bridge for an accurate reading. These do not give a very accurate reading of capacitance, and I'll tell you why that is in a moment as well. If you're interested, watch towards the end. We'll just check out and see how these types of meters measure the capacitance, because it's quite interesting and it's relevant. And it's useful knowledge to know if you're going around the board checking capacitors. Right, anyway, so yeah, temperature we got, which is fine. It doesn't come with a thermocouple in the box. I think it's a type K thermocouple, but I have got every one of these I bought has got a thermocouple, so I've got about 5 or 6 of those, so I can plug the thermocouple in and measure temperature. That's quite good. Frequency again, we can talk about the frequency in a moment. It hasn't got a great range, but useful for as long as you know its limitations. It's useful. If you don't know its limitations, it's going to catch you out if you're working on that type of circuitry. And so we covered all that. So also it's got a if I go on volts DC and hit the math mode, right, 1000 ohms, so 1 volt would give you 0 dBs on the display, and you can turn the mode on and it's in dBm. The mode you can change from dBm to decibels. Of course, in the decibel mode it's just a voltage, so it'll be 1 volt is 0 decibels. Doesn't note the load resistance that you're driving into. It's not actually loading the signal, it's just telling it what resistance you're driving into, or what impedance you're driving into, so it can calculate. So it's really a math function. That's why they call it math. So turn the mode off and you're back to volts DC, and that works for AC and DC and everything else. Now you've got a record function on here. Now it's not clear, I haven't looked in the instructions, but if you want to, you can see just how many records it will do. So if you hit record, you're on volts DC already, and if you go manual, let's clear that for that. So right, so if I go manual, it'll just take a one reading. So you're reading 1 DC volts and the voltage, and if I press it again, it's really the save button you're pressing, and you can clear it. So you go save, 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 save. If you put it if you press the back button and you go auto, you can't clear it. I don't know why they haven't put a clear button in the auto setup, do you? It doesn't, when it's auto recording, it doesn't display the data on the screen until you press stop. All right, so here you can set an interval for your record, so it will take a reading every 1 second at the moment. And if you hit the interval button, you can use the range button to scroll through the digits, and I could set it to 2 seconds if I wanted to. Can you see that? Can you see that? There you go. Look, so I can go 1, 2, 3, 4. So let's set it to a record every second, and then number of points you want to record, so up to 1000. So I guess that's a way of reserving memories, or say I want to do 1000 seconds of readings and I want you to stop, right? And then you press the start button. Sorry, let's go back to manual again. Back, manual, clear, and then back, auto, start. So now it's taking readings. And if I change can I change the ranges? I don't know if that's affected it at all. Do you know? Frequency. So I'm going through taking loads of readings now. That was my Mestec beeping and turning off on me. So we'll go back to DC voltages, and then we'll go hit the record button again, and then we'll go auto, and we can go end. So yeah, it does. Look, it's got DC voltage, DC current, and so on and so on. So yeah, there is a table in there, and I'm guessing via the comms interface on the back you can withdraw. There's no compact flash memory slot or anything like this, so this is obviously storing it in its own flash or non-volatile memory. So you're going to have to go in through the COM port and the command reference to get that data out. Shouldn't be too difficult. Right, what were we saying? Okay, so Yeah, and then you can scroll down. How do you scroll down on this? Do you go range? Oh, our arrow button. The arrow button's on the right hand side. On here, you can scroll through and look at your readings. Okay, so that's quite good as a data logger actually. If you've got a simple utility withdraw that data and you wanted to see what your mains voltage is doing. I've got a friend who's got a swimming pool pump, heat pump for a swimming pool, keeps cutting out. In the middle of the night it goes over voltage, and we've got a suspicion that it goes up to about 260 volts here, in which case the thing just craps out and just shuts down. It just says, I'm not playing at this voltage, I'm going to switch off, which is annoying because he comes down in the morning, his swimming pool is cold, but I don't have much sympathy with him really, or for him should I say. Right, so anyway, you've got your range. I'm not going to really muck around with the accuracy. One thing I did do, yeah, well, I could show you that, couldn't I, as well, when we do some measurements. Let's just do a few measurements on this. I'm going to turn my Rohde-Schwarz precision source on, and let's just see how accurate this thing is. I think the DC volts and the AC volts can be taken as read, really. It's just the capacitance settling time is the more annoying thing, which is minorly annoying because it takes a long time to settle down when you're just doing basic readings, and out one of these multimeter types, capacitance meters, you'll only ever get basic readings. Right, so hold on a second. Hello, Rohde-Schwarz is warming up. Right, so on out of my Rohde-Schwarz, I've got this screen lead. Yeah, it's up on the shelf. I've got an equipment rack in front of me. So let's just clip that onto there like that. Put the ground wire on like this. Oh, these things get really stiff, don't they? Really stiff. Oh, right, okay. So I'll set Rohde to 1 kilohertz. Come on, Rohde. 1 kilohertz and 1.0000 volts. Hertz. That's better. 1.0000 hertz. So this goes down to 1/10 of a hertz. This thing, and we'll stick it on frequency to start with. And we've got nothing at all. Why is it not reading the hertz? 1 kilohertz. Ah. I'll set it to 1.00 millivolts. 1 volt. 1 volt. There we are. So there you've got it. You've got a kilohertz in, give or take, probably a less than 50 millihertz probably. You've got 999.97 hertz. All right. And if I go relative, look, if I put relative on, it'll go 0. So you can see the fluctuation in the frequency. So for wowing, fluttering and things like that on tape decks, and also maybe signal drift on a low frequency oscillator, could be quite useful, couldn't it? It's not something you come across every day. If I set this to 2 kilohertz now, come on, there you go. It's reading 1000 hertz on 999.98, and if I turn red off, it will go to 2 kilohertz. There you go. So it's within a hertz or two, accurate enough for most people, 0.1%. That's going quite well. Now, if I put it to 1 kilohertz again. Okay, so we've got 1 volt going into 1000 ohms here on the dB reading, and we're in decibels. So if I increase that, so that gives, if I put it into dB measurement mode, we've got 0.02 dBs. It should be 0, but it's close enough for jazz. This is the signal coming from the Rohde-Schwarz, or 1 volt, 1 kilohertz sine wave. If we switch to different function, dBm, it will still read the same. No difference. So you can ask yourself, what's the difference between dBm and dBs? Well, dBm is always the power, and dB is the signal level. And the dB is usually used to be a reference to another signal. So when you say +6 dBs, it means doubling the level of the voltage. Yeah, I bought this because I wanted to be able to import DVM reading. Instead of having a camera focused on a DVM screen, I wanted to have a cheap way of having the DVM data imported into the PC and displayed on Outside Broadcast Studio, which is what the software which a lot of people use to do their podcasts and whatever onto YouTube or all the other platforms that are out there. And this has got a USB A/B connector, I think. That's the interface which allows you to control this and also retrieve all the data to port it into your PC. It's a simple USB interface. It's a serial port emulation running at the moment at 115 kilobaud, and I tried the software which is available from the OWON website, and it's terrible. Locking up, terrible interface. You can only control it from the PC. Once it's plugged in, these buttons don't do anything. It's a nightmare. So yesterday I sat down for probably about 3 hours and wrote my own utility in service, I suppose you'd call it, in Python, to import this information onto a window in Windows and then capture that window to be displayed in OBS Studio, Outside Broadcast Studio software, or anything you want, because it's a Windows, anything that can capture a Windows window, you can capture the data in that window, i.e. the display of what's being displayed in here on the on your PC. So also I put data logging in there as well, rather than relying on this run stop utility. I can do it in the PC to capture data logs and things like that. So it's I'll just cut to that now and you can have a look at it. It's written in Python. If you want a copy of it, you can have it. Go like that. Got the display on the screen there on the top right hand side and display on the unit, and you can change it to DC volts or whatever you want. Okay, and you can change that about a bit. If I just do this, I can move it. This is an OBS, of course. I can scale it. Alright, and you can change it. You can do frequency. Alright, so yeah, it's a nice simple thing. And when you turn the power off, this is bomb proof. This Python. If I turn the power off to the unit, you can see I've killed the power here. You'll see that's not the display. That's my. Let's transition back to that. The link will be down now. It's querying it. It's timing out. It's retrying. I put a 5-second retry on. Boom, no link. Okay. So the nice thing about this is when it craps out, it's self-restarting. I'd learnt from my banking experience, writing drivers for banking days, things like card readers and smart card readers, that you have to have a robust link. And it was quite nice to get back into, writing some application code. There you go. It just comes back. All right. So that's a Python utility which runs in Windows, but it's got all the options. You can change the font color. I can change the size of the characters. You can move the volts DC from underneath to the right of the display. You can change colors. You can change overall window size. It's actually working on a window in Windows, so this also could be used not only in Outside Broadcast Studio for doing things like podcasts, but it could be used for just putting a display mirroring what's going on here on your PC in a small, dedicated, always on top window. Right, so you've got the choice, and you've also got the choice of writing the data to the text file, so it will time log the data and just add it to a text file as well, so that if you want to do some logging, I've got my own logging utility. It is written in Python on Windows 7, 10, 11, it'll work fine, and it all works. You just basically plug this in, let it load up the serial. It's 115K board, and yeah, it'll just work. So I've tried it on a couple of machines, but it took me about 3 hours to write it yesterday. But now I've got this this display which I can move about and resize easily in OBS, and show you guys what's going on with future diagnostics. Cool, eh? Anyway, what else were we going to look at? Yeah, an interesting thing, how these things measure capacitance. That was it. I did mention that earlier, so I'm going to do it for you now. So where's my scope probe? I didn't realise how they worked. I sort of knew, but I haven't really looked at it in detail before. So I'm going to get a capacitor here, and I'll just show you how slow this is, so you can appreciate what I'm talking about. You might not even appreciate it. You might, if you work for OWON, you're not going to appreciate it at all, are you? Okay. So I'm just going to clip my clips onto the capacitor. It is a Rubicon, reasonable, just electrolytic capacitor. It works okay with polyester film and all that, but to be honest, I don't measure sort of polyester capacitors much with the DVM. I usually use this Handtech LCR meter, much more accurate, much faster, and it gives you more information about your cap as well. So let's take that off there. So we're done with the rakel, I think, from now. And let's just put that on to... Where's my cap gone? There it is. So I put it on my lead. Which one's positive? 2 yellow leads. That wasn't sensible. Alright, one on there. The leads won't, at this sort of 47 microfarad, the leads won't be really that significant wrong at all. Discharge it, put it on there, and then switch on the cap range, and watch this. That's how long it takes. You're going around the board measuring the caps to see whether the caps are blown up. There you go, you've got 49.16 microfarads. So it's pretty slow, wasn't it? I don't know, what was that, 10 seconds? If I just try the same thing on the old Handtech, not the Handtech, the Mestech. There you are, just to show you the difference. Right, let's short the leads out. Let's not give it a flying start. Shorten out the leads. Okay, short it out. Turn it on. Yeah, 49.96. So it's quite a bit faster, probably 3 times as fast as the OWON is. So that would annoy me slightly. And the other thing I was just going to show you is, I wonder if you actually put that in there. Put that back on there again. Short the leads out. I'll just short them together. I wonder if I go... There's no speed, is there? There's no speed change. There you go, it's done it now. Temperature math, joule math. No. You measure capacitance in dB, can you? No, surely not. Anyway, put cap on. Be nice if it just changed the range or the speed or something. I think that trigger's fixed. It's triggering quite fast, isn't it? I didn't set it to fast. Auto 50 microfarads. Oh, I see. This is the range it set itself to when it was discriminating the capacitor and measuring it, and it's gone to there. Okay. And you do relative capacitance. I don't know what you want that for. Does that go 0 if I do that? Yeah. So you could do a trimming capacitor or something, couldn't you? And just have lots of fun with capacitors. Life is a bit short, frankly. So if I put it in there and press dual display, what do I get? Nothing much. So the dual display is really for AC ranges to measure, to display the frequency, and also on the frequency you've got mode. You can have frequency or you can have pulse width, period, basically. Oh, so it's just in milliseconds, okay. But we're not on AC, but you can work that out yourself, can't you? Yeah, you can. So capacitance then, so let's see what the capacitance is actually doing. Let's put it on there. And okay, so let's power up the old Scopington. I'm going to put my output there, transition it to that. You can see the scope, right? You can see the scope. And I'll get my scope probe. Just around here a minute ago. I'll just clamp it onto the... It's pretty obvious what it's doing when you think about it. It's not the same method as used in the Handtech, and I'll demonstrate that quickly in a minute. I don't want this to be too long, boring video. Okay, it's boring, fine. Suit yourself. Be like that. Come on. There we are. Look, I've just clipped it on there. Look, that's the scope and the... Oh no, it's not. It's fallen off again. So I'm going to measure there. Thank you. Thank you for displaying the value. So if I go back to the scope again, look what we've got. We've got that's 100 millivolts per division, so we've got 200 millivolts sawtooth waveform, and what it's doing on this sawtooth is, you can see on the upward slope it's charging the capacitor, on the downward slope it's discharging the capacitor, and it's charging and discharging between two levels using a programmable constant current source and sink. And the time it takes for it to discharge or charge up is directly proportional to capacitance. Right, I don't know what it will go down to, but it says it will go down to nanofarads. I don't know if it will. Do you want to try it, do you? No. I'm sure it's fine enough for most people. For 80 quid, what do you expect? So that's what they do. They use a constant current source, and they auto range that current source to be in a sensible range where they can charge the capacitor for a set current time, a set current in a linear part of the curve. Because remember, it's exponential. The decaying exponential is the current, whereas the voltage rises exponentially, tends towards the actual supply voltage or the charging voltage. So in a small range, you can actually deduce the capacitance from the time. So it's using time to measure the capacitance using a constant current source to charge and discharge the current, and that's the voltage. That red line on there is the voltage across the cap. So that's how that does it. Now if we you notice that it's reading 49 microfarads. All right, we've got 49 on the old microfarads just there and on the screen. There you go. So you got 49.099 microfarads. Now if we take that out of there like that, put that to one side, I think we're finished with that now, haven't we? Good little unit. I'll let you know if anything really else goes pear-shaped on it, but otherwise I think it's quite good. I enjoyed writing the code. It's only probably about 200 lines of code, I suppose, but it's highly configurable. You can set all sorts of things I put in there, because I don't like to have any fixed parameters in my code. The window size, the character size, the font, the color, background color, the size of the initial window, the positioning of the window, whether the window is sizable or not. All of that's in the command line on the Python command line, run from a command window actually, but you can do a shortcut to it, or I could compile it into an installable executable, so you could install it on your system and access these wonderful features which I have created. Okay, yeah, rambling off again. So let's just put that in there, actually. Yes, no, let's not do that. This is an AC bridge basically, so I'm just going to get this capacitor off there, and I just want to talk to you. Remember that 49 microfarads, right? It was reading, and that's at a very low frequency. That was like something like 1.5 hertz or something like that. It was cycling the capacitor up and down. So if I turn this on, no, because you want me to see, I'm going to stuff the capacitor in, all right? I'm not going to get too picky over this. Stuff the capacitor in and then slide down. You can see the readings. There you go. So the capacitor is engaged in the hill, and let's zoom in on that display so you can get a bit better view of the display. Right then. So, okay, so all data sheets, most data sheets for electrolytic capacitors specify the capacitance at 100 hertz of excitation field, so that the voltage is 100 hertz, and that's what's being used to measure the capacitance. And at the moment we're measuring also the effective series resistor. If you imagine this is a perfect capacitor, then the ASR is basically a resistor in series. So the equivalent circuit is your 47 microfarad or 43.74 microfarad capacitor with a 0.7 ohm resistor in series with it. And you can see that the higher this voltage, the higher the ESR, the worse job a capacitor will do. For example, a decoupling capacitor, because with the resistor in series with it, you will get ripple on a power supply, for example, will cause ripple on the voltage because the capacitor's not there, because you effectively got a series resistance in series with it. So a high quality capacitor might have an ESR of 0.02 or 50 milliohms or something like this, but this is a very small package. The foils are quite thin, so there's quite a lot of resistance to it, so it's horses for courses with caps. But notice the 100 hertz, and that's what the capacitance on the data sheet is measured in, 100 hertz. I know there's a display brightness on this thing that you can change. Not going to bother with that. Right, so change frequency. What happens to the capacitance? Remember, this is not measuring the value of the capacitor on the label of the capacitor. This is measuring the actual effective capacitance in the circuitry as a visible looking at a cap. So if I just change the frequency to 120, you can see immediately the frequency, which is also equivalent to the actual, if you're doing a transient analysis on a capacitor or a smoothing circuit, it would be the speed at which the transient happens. So the higher frequency the transient, or the shorter duration of the rise time of the transient, the less capacitance you get. So go up again, 400 hertz, it's gone down to 42 kilohertz, you've gone down to 42, 4 kilohertz, it's down to 38. And you can see as you go up to 40 kilohertz, you've got 6 microfarads. And then if it's a 50 kilohertz, 20 nanosecond pulse, you've effectively only got a 1.8 capacitance, 1.8-ish microfarad capacitor, and an ESR of 0.16 ohms. So that's why you always have a polyester film or a multi-layer ceramic or a tantalum or something decoupling in parallel with an electrolytic capacitor, because they are not very good, or they're next to useless at high frequencies. Of course, it's a function of the amount of current you're going through, and if you've got one in a circuit, a capacitor that's coupling will always act as a slight bypass filter depending on the impedance of the actual circuit that it's driving into. Obviously with a high impedance circuit, there's less of a bandpass filter effect. Right, okay, so that's that. Okay, so, and when you wrap this in, you can see that if I go back to 100 hertz, there you go, and I put it in, boom, and the reading is reading nearly 6.5 microfarads lower than this, or this reads, because this is only measuring at 2 hertz, and no capacitors and no data sheets will be at 2 hertz. They're always specified at 100 hertz. So anyway, I hope you found that interesting. It's a bit of a ramble, but I'm you know, these background views, you might be thinking of buying one of these, in which case, good luck with it. Yeah, get the battery one. Get one, the 1241 with the battery in it, all right? And there we have it. So if you liked it, then just leave me a like, please, please, please. And then there's a little titty button in the corner which you can press to subscribe. It'll help me. And if there's anything you particularly want to see, put a note in the comments. I'm always doing projects and stuff all day. I volunteer at 2 repair cafes in the local area, so I'm seeing quite a lot of interesting things coming in for repair at the repair cafe. So if you'd like to see any repairs on anything particular, let me know, because I was repairing an East German vintage screen projector the other day for an old chap that bought it in, because it's got all these movies, family movies, which he couldn't watch. So, you know, all sorts of interesting stuff. If you want to see anything, stick it in the comments, because I'm back on stream now, because I'm more or less retired from the design work and just buggering about in here on my own, talking to you guys. Yeah, have a good one.